weren't here before. But if you know I haven't given you permission, feel free to let me know.
For Seth?
Okay. I'm smiling. I think I usually miss you somehow. Let me see where you are. Got you now. Okay. Anyone else? Mauricio, I don't remember giving, yeah, I guess I gave you permission. Anyone else? Let me look at the list a little better. Let's see. I think Deanna has it, yeah. Hugo, did I give it to you? Yeah, I guess so. Javier Espinoza. Yeah, I guess I gave it to you too. Okay. Help me out. Okay. Well, I think I've hit most of you, but anyway, feel free to let me know. Let me get my tablet up. OneNote. Okay, that's left over from another class. That's weird. Okay, I'll try it again. There it is. Okay. So can you see my screen?
Yes.
Yes.
Very good. So a couple things to discuss before we get into the math. So last time I handed back the exams, it was a little chaotic, but I think in the end it all got sorted out. There were some, the scores were good, and overall I was pleased. Maybe you don't know, the score in your class was 78.5. The score in the other class was 79, so they were slightly better than you, but it was roughly comparable. So I was really happy in both classes. I did reach out to some people who were struggling and asked if you wanted to talk to me. I might have some suggestions. After all, there's still 2 exams left, midterm 2 and our final exam. So in a sense, most of the grading is yet to be done in terms of the exams. So I reached out and talked to a few people, and I went over some of the scores. And interestingly, I made some adjustments. There was one person who ended up with a minor 1 point adjustment. But there was another person I talked to who I actually missed part of a problem that they had done. And so that person actually would have received 5 points more just because I missed that part. And I say would have because it turned out that same student got 3 points in something that she had skipped. So in total, she got a total adjustment of 2 points. But why am I bringing this up? Just to let you know that there are slight adjustments that could happen to your exam, but you have to do your part. And what does that mean? You have to go back and look at the exam and look at the answers that I gave you. And if you don't understand why, you know, or if you're thinking you deserve more, maybe you don't know what you got on that exam, on that particular problem. So one part may be if you're really mystified that your score is not where you think it should be, I think you should just set up a time to talk to me, and we can just go through it problem by problem, and I can tell you how many points you got. And then you can see where you lost points. Now, okay, I don't want you to get overly excited about this. I don't want like half the class asking me to regrade their exams. That's not what I'm suggesting. But I am suggesting that there have been some minor adjustments, a couple points or 1 point, something like that. So it might, if you couple the couple extra points you might get, plus some advice that might be helpful for you to do better next time, it might be you might want to consider actually setting up a time to talk to me. I'm very receptive to doing that. Okay, that's point number one. Yeah, question. Any questions? Okay. I think,
Oh, sorry.
well, go ahead.
I was just saying, so what day is going to be our test? Is it Friday?
Well, that's what we're coming down to now. So
Okay.
I don't recall, did we vote on that last time here or not? I think we did in my second class, but I don't, because they're at that meeting Friday.
Sure.
Yeah, I'm pretty sure we didn't. So why don't we take care of that right now? So today is the 7th. Here we are, Wednesday, the 7th. And Friday is the 9th. And next week, this would be the 14th, and this would be the 16th, and Monday over here would be the 12th. And I indicated before that we're going to have our second exam in this week. And so as far as I'm concerned, that just leaves any of these 3 days. And I don't recognize any of them to be a holiday or any other, I'm not aware of any big events going on that would stop us from doing one day over the other. So to me, any of these days are possible. And most likely you're going to pick Friday because that's what most of my students do from past experience. But let's just run the vote up and see how it goes, okay? So before voting, is there anyone who wants to put a little sales pitch in for one of these days over the others?
What about the 19th?
That's not, I don't see that on this chart.
Because we got the review kind of like later. I don't know if that means anything.
I think there's time. I think the review, oh, by the way, the review is attached to today's invitation, right? So I think there's time, particularly if you pick Friday. Okay, there'll be time because that's the rest of this week and all of next week. Also, the material that's less likely to be tested is not necessarily the material that we're going to be going over here. So we'll talk about what problems on the test you should be able to do. But I do want to try to stick with these 3 dates. Any other one want to make a pitch for one of these days, though? Okay, I'm hearing a little bit of feedback, so maybe somebody wants to mute himself. A little bit of a hum coming through. Okay, since so here's what I recommend. I'm just going to make it so I can see you guys. I'm going to stop sharing. And I just want to see roughly which of those days you're interested. I think it's probably going to be one-sided, but we'll see. We'll see. Obviously, if you don't care what day it is of those 3, then don't vote, because there definitely are people who do care. And, why not let them decide it if you really don't care what day of the week it is. If you do care, definitely vote. But vote for one, not more than one. Okay, that just muddies the water. Okay, so how many want to take it as soon as Monday and what was that, the 12th? Anyone want to do it that quickly? I didn't think so, but you never know. Okay, what about Wednesday, the 14th? Give me a thumbs up or some indication. I see 3 people. Yeah. Okay, so I think it's going to be a landslide, but let me just go follow through. What about Friday then, the 16th? Or yeah, that's right, Friday the 16th. So I'm counting 1, 2, 3, 4, 5, 6. Okay, there are a lot of no votes. Okay, but definitely Friday is the plurality, I guess. So we have a date. Friday it is. Okay. So let me go back to where I was. And I can now make this a formal announcement. So exam 2 will be Friday. Oh, 1A, April 16th. And for most of you, it'll be the normal time, which would be from 3 to 5. Remember, there's an extra hour set aside for this. So that's how it looks at this point. Is there anyone here who wants to start early?
What day did the other class select?
Well, the other class chose the last day of the week they could too, and that was their Wednesday.
So are we going to have the option to take it a different day again, or are you not doing that this time?
I don't know. Haven't thought about it too much. I don't mind you taking it earlier if that's what you really want. I suppose the 3 people who voted that way might prefer it. I don't think most of you will do it earlier. The real question is, do they get the option to do it later? Okay, and that's the trickier one. But yeah, I guess I'd have no problem with any of you wanting to do it 2 days earlier. Just let me know. Okay.
Can I be placed on the Wednesday list then?
Well, it's a little early. Just let me. Well, who is it right now? I'm
Zach.
trying to remember. Zach. Okay. Zach, you went back and forth a little bit. I forgot what day did you do it the last time. When did you do it?
Yeah, no, last time I did it on Wednesday. I think I was initially set to Friday up until like the last second.
Yeah, then you switched. Yeah, that's fair. That's fair enough. Just remind me when we get a little closer, okay?
For sure. Thank you.
Okay, you're welcome. Okay. So now let me give you a reminder, which I just heard about it in the department meeting. Do you guys know about Duo? It's sort of funny for me to be telling you about this because I don't know that much about it. I'm talking DUO.
Yeah.
Yes.
Okay, well, I've got a couple yeses, but I'm going to presume that there may be some people out there who don't know about it. A Duo evidently is a new, I don't even know what to call it, a new requirement, I suppose, that people who sign in for some Cal Poly Pomona features or I don't know, programs must basically give 2 different forms of identification. So up until recently, I guess, one form has been good enough, but now in order to make security tighter, they're asking you to sign in a second way. And I guess duo meaning 2 is that's requiring more than one form of identification. And I just signed in. I just signed on to this program yesterday, actually. And my understanding is there's a couple ways to go on this. If you have I think it's an iPhone or a smartphone or some kind of reasonable phone, then you can sign in over that. I don't. I have a very old retro phone. And because of that, my phone was not going to allow me to sign in according to that. So I had to secure what they call a little token, which Cal Poly Pomona provided me, which is a way to give them an additional passcode to let me sign on. Anyway, I did this yesterday. It seems to be working fine. You know, I could foresee problems if I'm not always at this computer. If I don't have my little token which generates the code, then I may have difficulty. But I don't have to buy a new phone costing hundreds of dollars, and I didn't want to do that anyway. So so I'm happy, and I think I'm okay. But I understand that students also have the same requirements. I think the the penalty for faculty was more severe than for students. If I didn't sign in by tomorrow, there would be some negative repercussions where I wouldn't be able to sign up for something. Blackboard is one of the things. I personally don't use Blackboard anyway, but for some people that would be a big loss. And there are other activities or programs that I could be missing. I think for students, I think you have a little bit more of a grace period. I think. But no, let me just ask, how many people here don't know about this or are just learning it now from me? Don't be ashamed. I just want to know if I'm talking to no one or to several people who know as little as I did. Okay, so I don't see anyone who didn't know about it. So it seems like you all know about it. Okay, then the real question is, how many of you have taken care to secure a second form of ID? Give me a thumbs up if you've already taken care of this issue. Yeah, that's what I'm worried about. Okay, there's a lot of thumbs up, but it's not universal. Okay, and so what I was told at today's department meeting, thank you though, and I'm very happy most of you have taken care of it. I was told today at the department's meeting that 90% of the faculty have taken care of this. So there's still 10% of the faculty who haven't taken care of it, and their deadline's tomorrow. Okay, so I procrastinate, but evidently I'm not the worst procrastinator. There are people even worse. Okay, but then I heard that something like 60% of students hadn't done anything about it. No, 60% had taken care of it. So 40% had not. I don't know. I don't know if you have the same deadline of April 8th that faculty had. And I don't know whether the penalty is severe, but I'm taking minutes out of my class here to talk about it because I was advised to do so. Because if you don't take care of this with tests coming up, depending how people may administer the test, and again, it's not me, I just do it through email, so it'd probably work for me. But if someone does it through Bronco or Blackboard or something, you may not be able to take your exam. And that's going to really, well, it's going to put you at a disadvantage for sure. And you don't want to be in that position. So for the few people who didn't raise their thumb or you know, our hands, and that is for the few people who have not taken care of this, please do, okay? And it's not so much for my class, though maybe even my class will be affected, I don't know. But probably some other class you're in will be. So, and if you're not sure how to do this, I think your best resource may be to go to the chat and just talk to your classmates, because I know everything I know about it. I've pretty much told you, except for me, there's a tech people around that would actually just made it very easy for me. I don't know if that would be the case for students as well. Any questions on this? I don't know what does someone know what the deadline was for students?
It's tomorrow too, I think.
It is tomorrow too. Okay.
Yeah.
Same date. Okay. Yeah. All right. So that's uncomfortably close if you haven't taken care of it yet.
It's just signing up, right? That's all it is for Duo.
Well, no, yeah, but it depends. If you have an iPhone or a smartphone, I think it's just signing up. But
Yeah.
if you don't have such a phone, then you may be in the position that I was in, where I need this little token. The token is free if you ask for it, but if you haven't asked for it already, they got to mail it to you. Maybe you can go by and get it. I don't know. But you know, but yeah, so in theory, yeah, it's just signing up. If you have a more modern phone, it shouldn't be a big deal. But if you don't, and not everybody does, then you're in the place I was in where you need this token. And that could put you behind the 8 ball a little bit because, there's not enough time to be mailed the token to meet tomorrow's deadline. So if anyone's in that position and you want to talk about it a little more, feel free to talk to me after class. But again, I'm hardly an expert on this, okay? But I do know that it could bite you. So if you don't take care of it, you don't want to be in the position where you can't take a midterm somewhere because you haven't done this. That's not where you want to be. Okay, any questions? Okay, so why don't we do some math? I'll talk about the sample test in a bit, but I'd like to get into some of the math if we can. Excuse me. Okay, so I'm just going to turn the page here. Yeah, I thought I was going to turn the page. Okay. So let me see where we are. I think we got interrupted a little bit with the test and a little bit with the spring break, but I think we now have an open field here. So let's go back to the section we're in, which is on recurrence relations.
Could we go over one of the homework questions?
Yeah, well, definitely. Which one are you interested in?
Maybe like F3. I just wanted to check something.
Sure. So he's asking about F3. Well, the homework was what, F3 through F5, something like that?
Yeah.
Okay. So I've got a request for F3. Does anyone have
F5?
F5? Okay, well, that's right. That'll keep us busy a bit. Let's do both. All right, so let's start with 3. So 3 is in this, it's in the little category here called the stamp problem. So let's go back over what it says here. Suppose you have 1-cent stamps, 2-cent stamps, and 5-cent stamps. By the way, I don't know if you folks even use stamps or for anything, much less if you're familiar with a 1-cent stamp or a 2-cent stamp. I'm not sure I've seen stamps like that for a long, long time. I don't even know if there are 1 and 2 and 5-cent stamps anymore, but it doesn't matter. It's a math problem. So the problem is to find the number of ways we can arrange in a row so they add up to a given value and cents. I'm just reading from the book, so we're on page 74. Okay. The order of the stamps is taken into account. Otherwise, we might have used coins, and we'll do that later. That's what he says. So, for example, he says 1 and 2. You add up a 1-cent stamp to another 1-cent stamp to a 2-cent stamp. That's considered to be different. Different than what? Than having the 2 in the middle. So it's what we've been calling order matters, right? And let AN represent the number of ways that the stamps can add up to n cents. Assume that there's an unlimited supply of each stamp. So that it's not like you have to worry that you don't have enough of any of these. You got more than enough of any of the stamps. So let's set up a little table. And the little tables that they're set up are, well, you'll see it on the next page too. But one way to do it is this. So suppose you want the total of the stamps to add up to n cents. That's not writing very well. Okay. And AN will be the number of ways to do that. Okay. So if you want the stamps to add up to 1 cent, well, then you just have to have a 1 cent stamp alone. And there's only one way to do that. On the other hand, if you want the stamps to add up to 2 cents, you could have 2 1 cent stamps this way on the letter or the envelope, whatever it is. Or you could have just the 2 cent stamp itself. So this would be one way and this would be another way. So there'd be 2 ways. You see what I'm counting? The number of ways you can line up the stamps so that their sum is 2 cents. And in this case, you might say, well, what if these 2 1 centers were reversed? We're assuming that the 1 cent stamps look the same, and you wouldn't count that as this part of order is not something we're considering, right? So if you reverse 2 1 cent stamps, that's not considered a different arrangement. Okay, what about 3 cents? Well, you can sort of build off of these if you want. So we could add, if we want the sum to be 3 cents, we could take a 2 cent stamp and add a 1 cent stamp to it. That would be one arrangement to get it up to 3 cents. Or we could do the reverse. We could have the 1 cent here and the 2 cent there, and that would look different on the envelope. What else is possible? We could have 3 1 cent stamps just lined up like this. And is there anything else? Let's see. There's no 3 cent stamps. If there were a 3 cent stamp, that would be another possibility. Rearrangements of this would not be considered different. So I think that's the answer. It's just 3. They want us to go up to 4 by counting directly, and that's what I'm doing. So if you want the sum to be 4 cents, well, again, the numbers are small, so it's easy just to list all the possibilities. You could certainly have 2 2 cent stamps in a row. We're talking about putting these stamps in a row. Or you could do 1 cent here, another 1 cent here, and then this being the 2 cent one. But once you start going down this way of listing them, the 2 cent could be in the middle. Or the 2 cent could be here at the beginning. And these 3 would be considered different because they have the 2 cent either in the last place, the middle place, or the first place. Oh, let me see. Is there anything else that we could do?
What about 4 1 cent stamps?
That'll work. Thank you. Okay. And is that it? I think so, just by exhausting all the possibilities. So what do we have? 5? Okay, so we have the start of a table for AN. AN is measuring the number of ways we can arrange these stamps so they add up to n cents. And so far, the sequence starts with 1. So if you want, you could think of this as A1, A2, A3, and A4. And that's all they're asking us to do here. So that's F3. That's quick enough. Any questions on F3? You know, I think I might as well just go through this because this is so much quick. Okay. At the bottom of page 74, he then says, now we introduce a recurrence relation for the calculation of AN in general. So the idea is we'd like to continue this table past 4, but we don't particularly want to do it the way we just did it. The way we did it, each of the ways I just went through this, we looked at, 2 cents, how many ways can you do it? 3 cents, how many ways can you do it? 4 cents, how you can do it. We really didn't take into account, some kind of recurrence relation. And now he says, let's do that. So we'll assume that n is greater than or equal to 3. That part is fine. Finally, assuming they're, well, let's see. Okay. Well, let me just cut to what he's going to here. So he says if what? N is greater than or equal to 6. Then he claims the following recurrence relationship holds. Then he says that an can be found by doing this and adding it to this and adding it to this. Okay. And the analysis for this is the following. If you're trying, suppose n is greater than or equal to 6. So in terms of our table, why don't we just make it that way? 5 cents is here and 6 cents is here and so forth. So suppose we're here further on. And he's saying, well, if the stamps add up to 6 cents, where were you when you had only one less stamp? Well, either if you had one less stamp, either the total at that time, well, what is the, if there was one less stamp, which is what this is saying. Now let me make sure I got that right. So it basically looks backwards. So why don't we do it for A6? It could be that the last stamp you put in consideration was a, what are the stamps we've got? 1, 2, and 5. So if we think of the last stamp added was a 5 cent stamp, then it would have been A1 plus that 5 cent stamp. So whatever A1 was, which in this case is just 1, if you add 5 cents to that, that's a way to get stamps that add up to 6 cents. But how else can you add up to 6? Well, maybe the last stamp that you included in the batch was not a 5 cent stamp, but a what? A 2 cent stamp. Sorry about that. Yeah. So if it's a 2 cent stamp, then before you added that together, you had stamps that already added up to 4 cents, and then you had a 2 cent stamp. Or, these are all ors, you can get A6 by saying the last stamp you added was a 1 cent stamp. And what you had earlier was that. And so there's, tracing back, there's 3 different possibilities. You could add a 5 cent stamp to this and get the sum to be n. You can add a 2 cent stamp to this and get the sum to be n. Or you could add a 1 cent stamp to this and get the sum to be n. So you could predict how the sum could be n by what it was one stamp back. If you think of the most recent stamp that you added. And that's describing all the ways that the sum could be n would be coming from these positions if you're just looking one step back. Now, in this case, what would it give you? It would say, it would give, well, we haven't done 5. Yeah, so what is A5? Well, you've got all of these ways to add, you can do the same analysis, all of these ways to add up to 4, which is 1, 2, 3, 4, 5 different ways. And then if you added 1 to any of these, that would get you a sum of being 6, and that's really what's going on here. So you can get so what I'm saying here is you can get a 5 by adding a 4 to a 3. And this doesn't make sense now, because if you go back 5 cents, and it would be A0, and it's like having no sense stamps at all. So the recurrence in this case would only be the first 2 rather than all 3. A4 was 5, and A3 was 2. It was 3. So you add these 2 to get 8. So this recurrence relation is only going to work once you're far enough along, which means n greater than or equal to 6. And this is the explanation of why, because if n were equal to 5, this would become A0, and there's not even an A0 on this whole table. The whole total started A1. So the recurrence for A5 would be this. You either, one step back, had all the ways the stamps could be arranged out up to 4, and then you added another cent to that. And that would give you, well, I can't even see them. Let's see. That would give you all of these. So there are 5 ways. Make sure I believe that myself. 5 ways where you could add up to 4 cents. Yes. And how many ways? 3 ways where you could add up to 3 cents. And if you introduce one more stamp here or one more stamp there, you will be adding up to 5 cents. Here you'd have to add up another 1. Here you'd have to add up to 2. So in this case, it's 8 cents. But from here on, then this full recurrence relation sort of kicks in. So it would be what? n being 6 would be this one, 5, 4, and what? 1. So it would be this one. Is that right? Yes. So you would take a 5, which is this, and a 4, which is this, and a 1, and that would give you what? 14 cents.
Wouldn't there be 9 ways to do the 5-cent stamp or 5 cents? Because you could also do 1 cent stamp.
Let me see. For the 5 cents, not if we believe this.
Well, couldn't we also just put 1 5-cent stamp, which would add 1 more way to do it?
Oh, yeah, let's see. If you have this 1 5 cents, yeah, that would work. Okay. Okay, so this is wrong. Yeah, so this is wrong. Thank you. Yeah. That should be 9, right? So the recurrence actually does work for what? For 6, right? No, we're trying to find 5. Wait a minute.
I think in the book it said to find A5, it would be the recurrence, then just plus 1 instead of plus the number of ways you could do A5.
Yeah. Yeah, so yeah, so A5 has its own special recurrence is what you're telling me, that it's 1 plus A4 plus A3. Yeah. Which is not the same as this. because this in general, when n is 5, this would be a0. So it's got a special recurrence when you're here. Thank you. But if you're past this, it would be this. So hopefully, let's do this one right. So, but this, now that this is corrected, this would be what? 1 back would be 9 cents. So A6 would be what? The 9 cent, which is what you are 1 back. And then 2 back, you're at what? 5 cents. And now, and then going 5 down from here would be what? A1, which is 1. I get this is 15.
So, Professor, quick question.
Yeah.
So does that mean like ace of 1 all the way up to 4? It's like ace of n equals ace of n minus 1 plus ace of n minus 2. And then ace of 5, it's like that, but then you add 1, and then anything above 6, it's like what you wrote in the box.
Yeah, this is the key one that we're interested in, because we're interested in going past the initial ones. So to be honest with you, I don't even worry that much about what the recurrence relationship looks at the start, because those you can just do sort of as we did over here on the side, just listing all the possibilities. But really what you want to know is once you're far enough along, what is the recurrence relationship that's going to govern it from then on? So and then on in this case is 6 on. So once you're past 6, this reasoning, which says where did you come from? Well, when there was one more stamp to add to the collection, you either came from a sum which was 5 less than n, 2 less than n, or 1 less than n. And you know the number of ways of doing those things. So it's a little bit like Pascal's triangle. Once you know the number of ways of doing this, that's still going to be the number of ways of doing the next one, because all you're doing is adding a 1 cent stamp to each of these, right? And the same for this, and here a 2 cent, and here a 5 cent. So yeah, go ahead.
I was going to say, is ace of 5 8, or is it 9? What did we?
It's 9. I think the correction was correct.
Okay.
Because I overlooked that you can get a total of 5 just by adding a 5 cent stamp, right? Because I was doing this, but this is wrong. I mean, it's incomplete. It should have been plus the 5 cent stamp itself, right? Okay. Now the rest of the way would be easy, right? So I think the rest of the way is F5. I can't believe. Let's look at it. Use the relationship to find the number. Well, okay, they changed the stamps for F5. But B would be what? Use the recurrence relationship to generate the values of A and up to including A10. So let's quickly do that and then go to the next one. So if we wanted up to 10, I need a little room here, so I'm just drawing this part. But we can now extend our table. So we need 7 and 8 and 9 and 10. And once we're past 6, this is what we are to use. So for 7, it would be this plus what it is at A2. So it'll be what? 2 plus 9 plus 15, which looks like what? 26, just keep me honest. And this one would be the sum of these two, which would be what? 41 plus what? 3? So that's 44 if I'm adding right. What about this? It would be this, and the 5. So 26 and 44 would be what? 70, and the 5 is 75. Keep me honest, because I'm just doing this on the fly. And then this would be what? 75 and 44. And plus what? Did I mess it up? I may have messed it up. Keep me honest here. So let's try them again, just make sure we're together. We were okay up to 6 to begin with, right? So it was this plus that, which was 26, so that's fine. And then it's this plus the 3. 28 and 26 is 44, I guess that's fine. This, and the 5, right? So 44 and 26 was 70, plus the 5, which was 75. But then I think I missed it here. It should be this. So it should be 74, 44. And going back to what? 9 should have been added, right? Yeah, that's my mistake. So what is this? 9 and 9 is 18,
128.
28. That makes sense?
Yeah.
I mean, it's easy enough to mess up, but I mean, it's easy enough to do. You just check. Okay, so now let's redo the next one. F5. Use a recurrence relationship to find the number of ways for 1 cent, 2 cents, or 3 cents stamps can add up to 8 cents. Okay, now we could do it the same way as we just did F3. But maybe it'd be better to work backwards. So if you wanted A8, you could have had everything add up to 7 cents. Or you could have had everything add up to what? 6 cents. So that's 2 cents less than the 8. Or you could have had everything add up to 3 cents less than the 8, which is what? 8.5? So I'm suggesting this is where you came from. If you're looking for the total of the stamps to add up to 8 cents, and if you think of what has happened earlier as being calculated, all the ways that could add up to 7, you could just add 1 cent to that, and that'll give you all new ways to add up to 8. All the ways that added up to 6, you could add 2 cents to that, that'll give you new ways to add up to 8. And here you'd have to add a 2 cents to that, and here 3 cents. So I'm sort of doing this one back down.
Is the third term supposed to be like a sub n minus 5 though? Because it's like above 6, or that's not how it works.
Oh, that's how it worked in F3 or 4. But here the stamps have changed. It's no longer 1, 2, and 5. It's 1, 2, and 3.
Oh, that's what that means. Okay.
You've got different stamps. Okay. I mean, these two are the same, but this is no longer a 5. It's a 3. So that means the recurrence relation has changed.
Right.
And the way I think of it is, if it's got to add up to 8 cents, and I just, what was the last stamp I added? Well, if it was a 1 cent stamp, and before that cent, it all added up to 7. If it was a 2 cent stamp, then it all added up to 6. And if the last stamp I added with the collection was oh, it shouldn't be 5. Yeah, well, the last stamp is a 3 cent one, which meant the total at that time was what? 5, so that it now adds up to 8 when you add the 3 cents. Okay, so this is how the recurrence would look. The only problem is you don't know these things, right? Okay, so if you already knew these, you'd be done. So this is an alternative way to do it. We could just start at the beginning and figure out what? A1, A2, A3, A4, A5, A6, and A7. And if we knew all of this, then we can use this recurrence relationship to get what A8. But this time I'm sort of thinking about going backwards. So what would A7 be? Well, if the sum of the stamps is going to be 7 cents, you might have had a sum being 6 and you added a 1 cent stamp. You may have had the sum being 5 and added a 3 cent stamp. Or you may have the sum being what, 4 and added a 3 cent stamp. So it's the same recurrence. Okay, but I still don't know these. It's the same problem, but my problem is getting a little easier to fiddle with. What about A6? A6, maybe the sum added up to 5 and you added a 1 cent stamp. Maybe the sum added up to 4 and you added a 2 cent stamp. Maybe the sum added up to what? 3 and you added a 3 cent stamp. But I still don't know these. But once I do, I'm going to be in business. What about A5? Maybe you had a 4 cent stamp and you added a 1 to it. Maybe you had a total of 50 cents and you added 2 to it. Or maybe you just added, added up to 2 and then you added, put in a 3 cent stamp. Okay. Well, why don't we keep going since we're doing this a little different way? What would A4 look like? Maybe all the ways you could add up to 3 and then you throw a 1 cent stamp onto each of those. All the ways you could add up to 2 and then add a 2 cent stamp to each of those. All the ways you could have 1 and then add a 3 cent stamp to those. Okay. Now, I think we're at a point where we can do everything here. A1, if the sum is going to be 1, you just got to have one cent stamp. So that one is known. What would A2 be? Well, now you got a choice. You could either do this from scratch or you can do it from the recurrence. Let's try the recurrence backwards because this is going to be interesting. So far, the recurrence is the same. It's adding the previous three values, 3, 2, 1, 4, 3, 2. But if I kept going backwards, what would it give me for A3? Maybe I had a 2, the sum was 2, and I added a 1 cent stamp. Maybe the sum was 1, and I added a 2 cent stamp. But that would be it, right? Because the sum can't be 0. Because the stamps are 1, 2, and 3. So the recurrence here looks a little different. So at the start, the recurrence is not quite the same. And what about A2? A2, one step back, you were here. So from here, we can now generate everything if you wanted to. Since A1 is 1, A2 would also be 1. 1 and 1 would give you A3, which is 2. This is 1, 1, and 2, which is what? 4. This is what? Yeah, I've got everything here. I just got to keep it in mind. A2 is 1. A3 is 4. 4 and 1 is 5. And A4 is 4. So I'm just going to list everything so I can just use it.
How come A2 can't be 2?
Oh, A2 can't be 2.
Wouldn't you add 1 to A2 and A3?
That's right. It's the same mistake as before. Same mistake I made before. Okay, so that's that. So let's redo this. So this is 2.
Because if you do it by hand, you could have a 1 and 1 and then
Right.
2 cent, right? So that's technically 2.
Yeah, no, it's the same mistake I made before. So thank you. Okay, so this one would be what? 1, which is 1, and 2, which is 2. So this is 2. A4.
Wouldn't you also have to add 1 to A3?
Yeah, because there's 4 ways to make it.
Yeah.
Maybe. Let's see.
It's like 1, 2, 2, 1, 1, 1, 1, and 3.
Yeah, so what you're telling me is that there might be a good reason not to do it in this order. Let me see. So you're telling me that, okay, where were you one stamp back? The sum was either 2, in which case you added a 1. The sum was either 1, in which case you added a 2. And here, you couldn't add a 3 because if you added a well, you could add a 3 to get this. You're right. So it's 1 again, right?
Yeah, because
Yeah.
if you write it out, like
Yeah.
each cent, you would have 4 different ways as well.
Yeah, so now, okay, so maybe it's better to go slower. A2, you're telling me, is it's either just a 2-cent stamp by itself or 2 ones, right? And that's giving us this. A3 is either a 3-cent stamp by itself, or it's a 2 and a 1, or a 1 and a 2,
Yeah.
or it's 3 ones, right? Okay, so, and that's giving us the 3. So so the start of the recurrence has 1 and 1 here, but I think from here on, it would be like this. So now, okay, that's the problem with the beginning. The beginning doesn't follow the same formula as the general recurrence. But now I think it's good. So I'm thinking that the rest of the way, we should be in business with what I did.
So is it better to start with like A1 with these kind of problems, I think, and then like work your way up, right?
It's a choice. You have a choice. If you wanted to get, it depends what they give you too. Suppose, for example, they gave you A7, A6, A5.
Yeah.
Somehow you knew that. Then why work it up from the bottom if this is the only one you're really interested in? But in this case, they didn't give you anything. So it's probably, you could go either way. It looks like you have to work through the first ones anyway. But once you get to when the recurrence doesn't change, you see here the recurrence has the same added, it doesn't look like this. The general recurrence looks like what? AN looks like AN minus 1 plus AN minus 2 plus AN minus 3. That's the general one that occurs from here onward, from there on. So if you were to ask me, maybe an efficient way to do it is maybe do the earlier ones until the general recurrence kicks in, which is where we are right now. And then the rest of the way should be smooth sailing. It should be 3, 2, 1, which would be the sum of these, which would be what? 6. This one would be 6, so A4 is 6. Again, how would you get A5? Now the general recurrence kicks in. To
And
get
A7
A5,
four, right?
you add these 3 together, right? A4, A2, A3, A4 to get A5. So that would just be what? 11?
But I think ace of 3 was, you said, was 4, right? Or no?
No, A3, I think
Because
we
there's
added
4
3.
different ways to get 3.
Okay, so you're worried about this one? It doesn't count those, didn't it?
Because if we said ace of 2 is 2, and then ace of 1 is 1, so it's 2 plus 1 plus 1. So that means ace of 3 becomes 4, and there's 4 different ways in your,
All right, but they didn't know results. Thank you. Is that what I had? That's what I apparently had. Let's see.
right? Or I don't know.
No, I think you're right. Let me see. Well, here they are. It's easy enough. To get E3, you're going to have a 3-cent stamp. You're going to have one 2-cent stamp, 1, 1. Or you could have this. So you're right. So this should have been 4. And what should have, okay. Well, let's see if we're getting this right. A1 is 1. A2 is this. And since we know A3 is 4, this should have been 1 again. Oh, but it was, right? 1 is 1, and 2 is that. This should have been 1. It was. So I think I just didn't record A3 properly. Okay. I think we're okay now. I think A3 is 4. A2 is 2. And the rest of the way we're using this recurrence relation, so it should be okay. So A4 should be this, this, and this, which is 7. A5 should be 4, 3, 2, which is what, 13? A6 should be 13, 7, and 4, which is what, 24? A7, how far do we have to go with this? Oh, what do we want? A8, yeah. This one is 24 and 13, which is 37 and 7. What is that, 44? To be honest. And then finally, A8, if this is all correct, would be the sum of these. So 4, 4, and 3 is 11. 4 and 4 is 31. Double checking on that. So I'm getting A8 to be 81. Is that what you get? Yeah, but the answer's in the back, so you can check.
Yeah, it's 81. So that's good.
Okay. Yeah, okay. Thank you for the help along the way. So, in summary, how would we do this? You're far enough along that you probably want to develop the general recurrence relation, which is this one. But in order to work your way up to using this, you need the initial ones anyway. So if you can figure out when this starts, this really started when you're at 4 or more. So you really need to do this one, and I guess A1 as well, separately, probably just by counting, which is more or less what we ended up doing. A1 was obvious, and A2 and 3 are these. Once you have those 3, then you could just use the recurrence relationship to work your way up to whatever one you want. By the way, this would not be hard to write a program for if you were interested in doing it.
So, Professor, with that being said, I was looking at the review. There's a review question. Question 3 is just like this, but it's asking for stamps of 1, 2, and 5 cent. It's basically a sub n minus 1 plus a sub n minus 2, and then a sub n minus 5, right?
Well, 1, 2, and 5 is the one we did, right? That was,
Oh, yeah.
so that looks like F3 again, except I don't know what you were at, what it was asking for. How many different,
I was just
yeah.
curious.
Yeah, we probably have it if we go back far enough. So is it 44? Let's see. 1, 2, 5. Yeah, it looks like the answer to that question on the sample test is 44. Apparently, how many different ordered outcomes that total 8 cents? And we already did this table for sure. Okay, well, I'm out of time. Let me just transition to the office hour. So I'm going to take a little water here, and we can do more of this. I think I've given you the sample test. Let me give you, and we spent most of the period here talking about the homework, which is okay. But let me give you more. Why don't you do F6 through F9 at least? So homework, I would say the homework would be twofold: sample test, and you can talk about which problems to do there. But some of the stuff you haven't seen yet. But also I would do F7. What did I just say? F9 or 10? At least through F9. All right, give me 10 seconds to get a little moisture in my mouth, and we can do some problems. That tasted good. Okay, maybe I should tell you which sample test problems to worry about. Since I just told you to look at the sample test. I would say on the sample test, you should be able to do number one. Let's see, how many 6-letter words coming from this, having no missed letters are there? Yeah, I think you should be able to do number two. And three, well, we just did in the process. Four, not yet. So skip four. Find the number of rearrangements. I think we did something like 5 for homework, so you should be able to do 5. Find the number of distributions. Yes, the distributions we've done, that's 6. 7 is more like the homework, so I would say you can wait on 7 if you want. I think we did 7B, but I think it was a special problem. So I'm not sure it's likely to be a sample. But okay, I'll put 7B as something here that we probably already did. Let me look at 8. I don't know. I'm not sure about 8. I'll put it out here. And 7A, I have out here too. So you may want to wait on these. Let's look at 9. Find the number of ways to rearrange it. Oh, we already did that. So 9A should be something you can do. That may have been on the first test. B. So I'm not sure how likely that it'll be on your test, but it's certainly something you could do. 10, I would skip for now. 11, you should be able to do. And 12, skip. And that's it. Okay. So you could do like roughly 2/3 of them. There's 12 altogether, and there's 4 that you told you to hold on. So try any of these. So we could talk about these now if you want, or we can talk about F7 through F9 if you want to continue that. Either one would be sort of a good way to continue going.
I have a question.
Sure.
For the homework, you just want us to attempt those problems. Do we actually have to solve them? Or when we submit the homework?
Are you talking about the sample test? Or are you talking about F7 through F9? What are we talking
The
about?
sample test.
Oh, I think you should do it. You should do it as a homework assignment. You should turn it in.
Okay.
Yeah, no, and because actually things that appear on a sample test, you should take more seriously than anything else. Because they could be on your test.
Okay, because I heard you say attempt them, so I wasn't sure if I was actually supposed to complete them all.
Well, I'm hoping you'll be able to do them all before we take our test. But you may not. Some of these, the ones on that I put on the side, we haven't covered all the topics for. So that's why I'm saying wait on these. But some of these we'll get to before our test because we still have 2 more lectures, right? We have Friday, we have Monday. And so anything I cover in those 2 lectures still could be on this test, okay? And that could be some of the topics that I put under wait. So when I say attempt, what do I mean by attempt? You could attempt something we haven't covered, but I'm suggesting you may want to wait just because it can become easier later. Or it could be something over here that we did before, but you forgot how to do it. So you just be attempting it at this point.
For the
But
test, oh, sorry.
No, go ahead.
No, I was just gonna ask, like, for the test, is there like a cutoff of like what is gonna be on it? Like, oh, we're gonna go from here to here, and any more materials for the following test?
Yeah. So more or less, I haven't okay, I won't say this is 100%, but I'll firm it up later. More or less, it's the material we covered after the midterm until Monday,
Until this Monday,
this coming Monday.
this upcoming Monday. Okay.
Because that'll give you a chance to do it for homework and talk about it. And
Mhm.
yeah. So that roughly that's the material you should be ready for. I might modify that. I mean, suppose I do something on Friday and no one understands it and I just don't want to give that on the test, and then I'll change it and carry it over into the final. But right now I'm being optimistic that the material that I give you on Friday and even Monday, you'll be able to understand well enough to do well on Friday.
Could we go over like some of the review maybe?
I'm happy to take the, yeah, which ones do you want to take?
I mean, if nobody else has a question, I guess maybe, I don't know, number one, some of those are kind of, I know they're kind of easy on some, but some of them are like really weird too.
Number one on the sample test.
Yeah, like finding the coefficient.
Sure. Number one on the sample test is a reasonable request. Let me see if anyone else has anything else. I mean, you can bounce back and forth. We can do some of these, we can do some of these. It's whatever you feel comfortable with. I mean,
Professor,
yeah, sure, go for it.
are you allowing us to take the exam with the other with the Monday, Wednesday group? Like just like how you did it last time.
Yes, yes. And that part I have no problem with. I think I'll probably end up doing what I did last time, where you could take it either day.
Okay.
Yeah. It's a little bit of a headache, to be honest, because I have to keep track of who's where and all of that stuff. But that didn't seem to be a big deal. It seemed to work out okay last time.
Yeah,
So yeah,
because,
Rasha may help you especially if you have, I think last time you would have had 2 tests on the same day or something like that.
yeah,
Right?
yeah, for sure.
It may be the same situation for you. Yeah.
Yep.
So sure.
Thank you.
Yeah. Okay, I've got a request for number one on the sample test. Do I have anything else requested?
Mine is because I was studying for the midterm, and so I was doing some of the older homework.
Uh-huh.
And there was one homework that I kept messing up. We could go over it. It's an older question.
Sure. Which one is it?
E27A.
Okay. That's fine. I'm happy to take requests like that. That's fine. Anything else from anyone else? Okay, why don't we do these two and, we'll see how it goes. If that's it, that's it. And if you got some more, that's fine too. So let me see if I have the right test in front of me. Yeah, so number one on the sample test is sort of the multinomial coefficient one, right? So it's asking, find the coefficient of x squared, y to the fourth, z to the first, in y plus z minus x squared plus 2 to the 9th, right? Okay, so this in the test that I just handed back, this would have been like a binomial theorem kind of problem. But this is not binomial because you just don't have 2 terms, you got 4 terms. So it's actually, I guess, I don't even know, quadnomial. I don't think they call it that, but anyway, you've got 4 terms. So the thing we need to remember is a plus b plus c plus d to the n. And what does this look like? it looks like we could fish it out of the book, but I think I could remember it for the most part. Say N1, B N2, C N3, D N4. What goes in here? The multinomial coefficient N, N1, N2, N3, N4. And where do the n's go? The ni's go from 0 to n. So that's the multinomial theorem. It's similar to the binomial theorem, except you get two more terms. And instead of having binomial coefficients, you have multinomial coefficients. Okay, so in the case that we're dealing with here, n is 9. And then just associate with everything with what it should go with. A should go to what? Y. B should go with what? Z. C should be associated with what? Minus x squared. And D should be associated with what? 2. Okay, now we want this coefficient. So when this coefficient occurs, let's rewrite this in terms of this. It's really x squared. Yeah, okay, it's a little tricky that way. Yeah, maybe let's start with the easier part. What's the easiest part? N is 9. So that part is fine. And so we know that, oh, and I guess I should have said here, N1 plus N2 plus N3 plus N4 add up to N. So the N's all add up to 9. So the coefficient of A, which is corresponding to Y, is supposed to be 4. So I want N1 to be 4. Does everyone see what I'm doing? I see that Y corresponds to A, and I'm asked for the coefficient of Y to the 4th. So I let N1 be 4. What would B correspond to? Z. B is corresponding to Z. That's the second term here. And we want the coefficient of, am I reading that right? Yeah, that's Z to the 1st. I don't know. That's correct. Yeah. So that would tell me that I want N2 to be what? 1? Okay, so I'm peeling away everything I need here. Maybe I can look for coefficients of 2. Well, there's nothing here with a 2. I don't see a 2 to any power. So that means the coefficient of 2 must be 0. Coefficient of 2 is N4. So N4 must be what? 0. And the only thing left is the sort of the trickier one, which is C. And C would correspond to having a power of what? 1, because I want x squared. It already has an x squared in there. So I want N3 to be what? 1. Okay, maybe that's the hardest part of the problem, figuring out what all the n's are. Does everyone see what I did, or do you have a question? I sort of did the easier one first. I knew x squared was a little tricky because of this, so I left that to the end. But A was y, and I knew I wanted that to have a power of 4, so that told me what N1 is, and so forth. Now, if I did all this right, it should add up to 9, and it doesn't, so I messed up. Why 9? Let's see. Yeah, because they gave us this to begin with. So something's off. Well, maybe not. Let's see. Let me make sure. I think it would still work out. Let's see. So when I do, let's just write it all out. So A is y, y to the n1, which is 4. Okay, and then B is z, and then z to the n2, which is 1. And then C, which itself is minus x squared. And the power on that is just what? 1? Yes. And then what else? D is 2. And the power on 2, since there isn't any 2 here, would be 2 to the 0. Okay, so with all of this said, let me see.
Wait, why is it 0 again?
There's no 2. This term has no 2.
But
So,
isn't 2 part of the...
yeah, 2 it should be here. So that means you're not choosing any 2's in the product.
It's because 2 to the 0 becomes 1.
Yes,
So we're trying to get it to look like x squared, y to the 4th, and then z to the 1, I think.
right. And there's no 2 here. So the only way,
The n's equal to 9?
well, they do, but here's how you have to look at it. The power on x is 2. So 2 and 3. Let's see. Oh, no, there is a problem here. Let me see. What am I missing? Missing something. Let me look at
Oh,
this
if you
again.
put n4 to be 3, that 2 is just part of the coefficient, right? What we're looking for?
Yeah, the coefficient I haven't even got to. That's this over here. But I'm trying to make sure the power here is correct. It seems to me the power should be 9, but it's not really happening here. So what's going on? I don't know. I think something's fishy about the problem, because the coefficient, anything in here, the exponents should add up to 9. And even if you're willing just to make it x to something, it's still not adding up to 9. It's adding up to 7. So something's strange. Let me see.
And it's a typo?
We've done this problem before, I think, or something similar where we did.
Oh yeah, no, something similar for sure, but I think there may be something wrong with this one.
But
Let me look.
last time it was okay to put because the 2 would be part of the coefficient, not part of the term, right?
Well, normally not if you have the 2 here as one of the 4 terms. I'm thinking of this as the 4th degree expansion. If you want to put the 2 as part of the terms, let me think about that. No, hang on. Let me check something. Let me check something.
Maybe the coefficient, they're supposed to be like a 16, because then you have 2 to the 3rd power. Maybe it's like a typo right there.
Yeah, I'm trying to see if there was a mistake, but I don't know if I have any recording of this. Let me see.
This is problem C46C. In the
Oh,
book.
is it exactly the same?
Exactly that problem, yeah. And when we did it last, we did our n4 was 3.
All right, now you got me looking in a different direction. Hang on a second. Okay, so which problem are you saying this is?
C46C.
C46C. I will look it up. You are correct. So we must, did we do that problem? We probably did.
We did it in office hours, on the 15th of March.
Okay, let me see what I did. Let's see if we can recover it. Because it didn't look that familiar. I didn't know it was the exact same problem we did, but that's even better. Oh, but who knows when that occurred? You said, what was the date?
It was March 15th.
Oh, that's like 3 weeks. May not be so easy for me to find. Let me see.
Yeah, we did.
And it's what problem? It's E.
Yeah,
Yes.
your N4 was actually 3.
All right, then let me, since I think it's going to take a little more time than I have to find it. So let me just go to what you have. Do you have the solution in front of you? Maybe you can just help me through it.
Yeah, N1
So-
was 4, N2 was 1, N3
Okay.
was also 1, and then N4 we chose to be 3.
Okay, so this is the mistake. Okay. But if I choose that to be 3, is that what you told me?
Yeah.
Then definitely everything adds up to 9. But, okay, that'll work. That'll work. Because then you're doing what I forgot who it was who suggested. You're tucking this thing in with the coefficient. Okay, so it's a little trickier than I thought. But I did it this way last time. Okay, so maybe I was more on top of this problem last time than I am now. But I see what's going on. Thank you. That's what I needed. Why? So instead of N4 being this would have to be 3. Why? Because the sum of these have to be 9. They all have the same degree. When you do the expansion, N1 plus N2 plus N3 plus N4 has to be 9, which is the power of the thing. So that means this would have to be 3. So then 4 and 1 and 3 and 1 would add up to 9. Okay, so do that. And then, yeah, what would go in here? It would be 9, choose 4. That's a 4. It looks like a 9, but it's not. 4, 1, 3, 1. Okay, and then in order to get the answer, this is part of the coefficient here. But so is the what? The 2 to the 3. And so is the -1, right? So everything else that you're supposed to isolate is this, x squared and y to the 4th. Sure, perfect timing. I'm just finishing a problem. I'll be able to help in 3 minutes. Good time. Yes, I could help. Yeah. So I got to do a little pet control here, but I think this is going to work out in the meantime. Anyway, I'm combining y to the 4th is there, x squared is there, z to the 1st is there, and the coefficients, this gets blended into that. For some reason today, I wasn't thinking of blending this thing into the coefficient. But it's the only way out. Why is it the only way out? Because the degree of these things have to add up to 9. And my assigning this 0, I assigned it 0 so there'd be no 2 here. But that doesn't work because then the ends don't add up to 9. So it has to be this. And then this just gets blended into the coefficient. It's a number. Thank you for the help. And I'm glad we did it in office hours, and I'm glad you had it recorded. Okay. And I'm sorry I missed it, but do you follow how it works now?
So what's the final answer? Is it negative? Like
Yeah, it would be negative 2 to the 3rd, whatever. That's 8, 9, 4, 1, 3, 1, which you could figure out. It would be. Look, I'd be happy if you have this, but if you wanted to figure it all out, it would be this. whatever that all turns out to be. It would be everything other than the y to the fourth is e to the first x squared. Unless you want to know what to multiply that by. Okay. Maybe I'll take the opportunity to get my pet into the car. We have one more problem to do, A27A. Why don't you look at that in the meantime, get started on it? And also look at some of the other sample test problems. So actually, I was beginning to think this was a bad first problem, but it's a reasonable first problem. Very reasonable first problem, considering it's a homework problem, right? So anyway, I'll see you in a couple of minutes after I come back. Okay. So did we solve E27A? Whose was that? Was that Dylan's or someone else's?
Yeah, that was mine. I always get stuck at the when I do my inclusion exclusion. I always get stuck at the end. I think I mess up one of my like A union B union C.
Yeah, okay, well, let's just do it. It looks like something we did in class. So I think even if we get a little mixed up, I think we probably have it written somewhere. But let's see how it goes. I've got a page. Put some lines on here. And off to the races. So E27. Yeah, I think I did this for the other class, actually. Use the result of E25 to count the rearrangements of the string. So I assume it's part A that you're really asking. Is that right?
Yes.
Okay. Rearrangements of the string 1, 2, 3, 4, 5 having exactly one element in its original position. Okay. So I think I would say I'm trying to figure out the sets. I think A1 would be 1.
In its right position.
Yeah, is that what you did?
Yeah, I did 1 in its right position, then so forth for the other ones until I got to 5 in its original position.
Okay, so that would be my initial take on this. So I think we're in agreement to begin with. It'd be up to A5. Yeah, and 5 is in its original position. Is in its original position. And it's easier to visualize if there were only 3. So let me just visualize it for 3. Suppose we just had 1, 2, 3 instead of 1, 2, 3, 4, 5. Then it would be A1 is in its original position, A2 is in its original position,
yeah,
and A3 is in its original position. And that way it's easier to picture because it would be like this. This would be A1, this would be A2, this would be A3. And if we're trying to count all the ways exactly one element is in its original position, then we're trying to find the shaded areas here. Here only one is in its original position. Here only 2 is in its original position. Here's only 3 in its original position. And the fact that you're just in this part of the diagram means that none of the other ones are in their original position. So it would be the same kind of deal as this, except there'd be 2 more sets and it would just be more confusing to draw the picture.
Yeah, that part I understand. It's because I was able to see the answer by looking at it like that, but I wanted to practice on my inclusion exclusion in terms of doing the unions.
That's where I'm going.
Yeah, I couldn't get the answer.
Okay, so let's just go through. So it should be this, right?
Yeah.
Because either 1 is in its original position, or 2, or 3, or 4, or 5. But it's not that, actually. It's I got the wrong thing. It's N1.
Yeah.
N1 means everything is its original position. And that would be what? That would be S1 minus 2S2 plus 3S3 minus 4S4 plus 5S5.
Yes.
S5, sorry. Okay, so that's what we need to calculate. So we need to calculate all the S's.
Yeah.
Well, I lost my page. Hang on. I'm back. Okay, so let's start off with S1. S1 would be A1 plus A2, etc., up to what, A5?
Yeah.
Okay, so A1 would mean
1 is its original position.
One is in its original position, period. Okay, so what does that mean? That would mean
the others aren't.
Yeah, 1 is where it should be, but 2, 3, 4, and 5 are not in their place. So how many ways could that happen? 9. If all of those are not in its right place, that's D4, right? Which is the number of ways you could derange 4 things. And that's, I think you said it, that's 9, right?
Yeah.
So that would make this 9.
So it'd be 5 times 9 for S1.
Correct. So you're fine so far. You're doing it, I think, just fine. Let's keep going. What about S2? Well, S2 are the intersections, right? All of these things. And well, how many are there?
It'd be 5 choose
Five choose
2,
5 choose 2 is right, which is what?
10.
Should 10, yeah, 10 of these. Maybe the last one, A4, A5. All right, so this one would be 1 is in its right place, and 2 is in its right place. And
The ways you can rearrange 3 is 2.
it's D3, which is 2, right? Yeah.
Yeah.
Number of the arrangements. So it's 2 times 10, which would be what, 20?
Yeah.
Okay. So far, we have S1, which was 45, minus twice
40.
S2 was 20, no? I think so.
Yeah.
So that's where we are. Keep going. Okay. S3, things that look like A1, A2, A3, right? And this would be what? 5 choose 3.
It's also 10.
Also 10, correct? But what this would say, 1's in its right place, and so is 2, and so is 3. So these two, there's only one way to get it. And so let me see, am I doing that right? Yeah, so there's 2. Now, hang on a second. Now I'm getting confused about something. Did we do this right? Let's think about this. Even go back to the first one. So if you want this, this would be in its right place. But why is it this? That's saying everything else. Okay, I'm beginning to wonder about these things. Go back to A1. A1 means what? 1 is in its right place. It doesn't mean that nothing else is in its right place, right? So I'm wondering, when I'm thinking twice about that. Now, it's interesting that I did exactly what you did. So then now I don't know whether that should make me happy or make me sad. Let me think about this. A1 means what? A1 means...
1 is in its original position.
I think it really means only 1 is in its original position, right?
That's what I interpreted it as.
Yeah, okay, so only 1. And only this and only that. Then we're all fine, and then it's all making sense. Okay, so let's stick with this. So then this would be how many ways? D2, that's just 1, right? So it's 1 times 10, which is 10.
Yep.
Okay, so now where are we? We're back up to here. It's 3 times S3 rather. And S3 I said was what, 10?
Yeah.
Okay. Yeah. All right. So now S4, things that look like this. So there's 5 choose 4. There's just 5 of these. But if you want this one, this would say 1, 2, 3, and 4 are in their original position, and that would mean 5's in its original position as well. Okay, so that would mean there's only one way to do this, have everything in its original position. And that would be 1 times 5, so it's just 5. So that would be minus, what is it, 4 times 5? Okay, and now the last one would be, oh, I lost the page again. Hang on.
Wait,
Sorry
wait.
about-
Is not a derangement? Or
Say
did
it
we,
again?
for S5 is not 0?
I haven't got there yet, so I don't know
thought
what
it
it
was-
is.
No, I mean S4.
Oh, S4. S4 is saying that 1 is in its right place, so is 2, so is 3, so is 4. And that means automatically 5 is.
But I thought we
Is
were
it-
counting the derangements.
No, we're counting how many elements are in this set. And if all of the, if the 1, 2,